Hi, we are engineering brothers, and once again we have considered our another nature of the poles and what seems to be the corresponding response for our system. And at the last stage, we should comment on that considered roots, whether that roots or whether that system is stable or unstable over here. And I have already analyzed in our previous videos over there. So first of all, we should look at our poles at the S plane over here, and quite naturally you can see that the complex conjugate poles are placed at the g omega axis or at our imaginary axis over here, and the points are given over here. Now let us just write down over here our important plots, that is plus minus of g omega over here. These are our plots that are situated at our imaginary axis over here. And how do we get this mathematical expression over there, that I am just going to show you over here. Now quite naturally this is the position of our poles over there, and we can look at just by considering our S-plane diagram over here. Now this upper cross that actually do indicate the plus j omega over here, and this lower cross which is the position of our poles that are actually to give us the minus j omega over here. And we have considered s is equal to plus minus j omega over here. That is the considered points for, or that is the considered location for our poles for our given waveform over here. Now how do we configure, or how do we consider the transfer function with the help of this given system over here? First of all, the transfer function definition will be output divided by input, which is cs divided by rs, and the denominator do have the expression for our a divided by our these are our number of points that the pole is located over here. Now the first point will be say plus of g omega, and the second point will be say minus of g omega. Okay, now what is the considered analogy in this case? I can say that this one will be s minus of j omega. If you just do transfer this j omega to the another side of our equation, we are having s minus of j omega, and the another one will be s plus of j omega over here. This one will be s plus of j omega. Now once again, this is the form of our a plus b and a minus b factor over here, and quite naturally the formulation will be a divided by a square minus of j omega squared. Now we do know that according to our analogy, j is equal to root of minus 1, and if you just do square on both sides of our expression, we are having j square is equal to minus 1. Now instead of considering our analogy for our considered j square over here, in our next step we can write this expression as a divided by a squared minus of j square omega square. Now instead of considering this as our j square over there, we can write that one as our plus, because minus minus actually do give us the analogy for our plus one, which is a divided by our a squared plus omega square over here. Now once again, if you just say that we just do require to apply the impulse input over here, now quite naturally the rs will be 1. Okay, now let us say at this point we are having our transfer function, that is quite naturally cs divided by rs, and the expression seems to be this one, which is a divided by our s squared plus omega square. Now if you just do apply the impulse input on that given system, the rs will become 1. Now the rs is 1. Now if you just put the 1 in our given expression over here, we are having cs divided by 1, which actually do give us a divided by a square plus omega square. Now we are at the last stage. Now in this case, if you just do apply the inverse Laplace on this cs factor over here, now if you just do apply the inverse Laplace on this equation of cs, which is equal to a divided by a square plus of omega square, the cs will become ct, and this is quite naturally a is constant, and 1 divided by a square plus of omega square, the inverse Laplace of that factor will actually give us the sine of omega t factor over here. Now this is the time domain equation over here. Now let us just do plot that over here. Now if you just do plot the ct versus time waveform over there, we can do realize that the peak value of this curve is a, and it has started from 0. Because of this sine waveform over here, we can see that the waveform do have started from 0 and it has got the peak value of a, and the oscillation will continue over there, but the oscillation is not increasing or decreasing in any way over there, as it is keep on moving with the same amplitude with respect to time over there. Now according to our analogy on how do we comment that whether the system is stable or not, we can say that as the oscillation do have the constant value, or the oscillation is not increasing or not decreasing in any way over there, we can say that this system is marginally stable. Why? Because it is being considered at the middle stage in between our stable and unstable systems over there. Now we can say that the said system of our CT is quite naturally our marginally stable over here. I want to repeat this portion once again. First, we will look at the S-plane over there and what is the plot, or what is the plotting points of our poles over there, and according to that points, we have considered our much needed S points over there, which are S is equal to plus minus of j omega over there, and we have considered that as per our transfer function analogy over here, which is Cs divided by Rs, which is a divided by this one, and we have applied the a square minus b square formulation over there, and we do know that j square is equal to -1, and we have considered that value over here. Ultimately we are having this value. Now at the latter stage we do require to apply the impulse input over here. Now quite naturally the RS value will be 1, and quite naturally CS is equal to a divided by a square plus omega square over there. Now at this stage, if you just do apply the inverse Laplace on this given equation, we are having CT is equal to a sine omega t over here, and in our next stage we have plotted that which is been considered as our CT versus time factor over there, and after we have plotted that, we are having considered that the oscillation do have the continuous oscillation. We can do realize that the oscillation is continuous, but the oscillation values are not increasing or decreasing in any way over there. That is why we can comment, or we can say that the said system is marginally stable. I hope you have totally understood up to this one. If you still have any doubts, please let us know in the comment section for better understanding. Do like, do share our videos, and keep following our channel. Just wait for my next part. That's it. Thank you and goodbye. If you like my video, so what are you waiting for? Please do subscribe my channel, hit the bell icon for more updates, and stay tuned to the channel. Thank you and goodbye.